Back before COVID, Dr. Gregory asked the Science Maker Lab if we could help her to build some apparatus to help with her spinal degradation research. This equipment and the user interface box that goes with it is a result of that lengthy collaboration. The equipment needs to flex a section of spine to fore and aft endpoints across a certain range at a certain speed and for a given number of cycles. All of these need to be adjustable. Therefore, several modes of operation were required to set these parameters and to test them, and then to finally run it in a sweep mode where it sweeps several thousand times. To make this all happen required a microprocessor and about 1,000 lines of code. There were many prototypes and many conversations with the end user, Dr. Gregory, and her researchers to figure out exactly what specifications were needed, and then a little bit of head scratching to figure out how to make the code perform those functions. As with any prototyping project, there were delays, there were lead times, there was equipment failures, there was equipment that didn't do what we needed it to do. There were specifications that changed as we discovered new capabilities. And of course, there were learning curves as the project threw us unexpected challenges along the way. The first half of this project was the design of the mechanical apparatus that would actually physically move the spine. This took place in several stages. We first modeled the concepts on the 3D CAD and then submitted them to Dr. Gregory for her approval or dismissal. Because good equipment is critical for good data and good data repeatability, and because we knew it would be very expensive to get this equipment made, we wanted to get the design right before we sent it to a machine shop to be manufactured. When we thought that we were very close to the correct design, we made a copy on the 3D printer, assembled it, and fit it into Dr. Gregory's apparatus in her laboratory to make sure that it fit and to make sure that it moved as it should. Although this took a lot of time on the 3D printer and used a fair bit of 3D printer filament, it was far cheaper and far faster than getting it done at a machine shop incorrectly and having to redo it. As we like to say in the lab, slower is faster. The next stage in the process was to write code that would control the motor that moves the specimen. Because we were waiting for several weeks for delivery of the motor we needed, during this time we made a small experimenter box that had a small motor in it that runs the same as the larger motor, and much of the code was worked out on this box. Some of you may have seen or even used this box in displays in the science atrium or elsewhere. Naturally, once this box was up and running, Dr. Gregory and her researchers were brought in to test it, try it out, and see if it worked for their requirements or if it even gave them any ideas for any new requirements. When you're developing a new product, it's a real luxury to have that level of access to your final customer. Involving the customer in the design of a product is a great way to ensure product market fit. The final design step of this project was to create a user interface that walks the end user through the processes of setting up a sample and getting it ready to run in the order that they would do it in the laboratory. We've been watching the machine step through those processes as I've been talking here. We hope you enjoyed sharing this project with us, and we hope to see you sometime in the Science Maker Lab. Thanks for watching.